Hi guys, welcome to this talk about slowly changing dimensions in depth. In this talk, I will talk about slowly changing dimensions as it is applied in the context of the star schema, architecture, or the dimensional modeling. We'll talk about the theory behind each slowly dimension type, and we will see how it's practiced in the real world. So let's start by who am I? My name is Nir David. I'm a senior engineer currently working at Monday.com. In the past, I've been CTO of 2 startups, and I have over 10 years of experience in engineering. You can follow me on Twitter at SneerD, or you can go to my site sneer.dev to see other programming and technical content that I create. So let's start off by first mentioning a prerequisite. This talk assumes you already understand what a dimensional modeling design is, what is the star schema, what is a dimension, what is a fact, all these kind of things. If you feel you have a gap in these understandings, you can go to the link here that will also be on the description of the video, where there is a talk, an introductory talk that I gave about how you do data warehouse schema design and how you design a dimension, a fact, all the type of facts, all the types of dimensions. So it's all there. But here I will go deep only on slowly changing dimensions, which is a very specific type of dimensions. Another thing to mention is a site I recently created, which called Awesome Data Engineering, which you can see on your screen right now. This site is a gathering of resources for a complete learning path of data engineering. So I took all the subjects by the order that is reasonable to learn them of data engineering, and I listed great free resources, books, courses. It's all there, and if you need some direction, this is a great tool. So let's go forward and start with the talk. This is the agenda for this talk. We'll start by discussing why we need slowly changing dimensions, what is the rationale and the business need for them. Then we will talk about each type. We'll start with type 1 and 0, which are to retain the original and override the values. Go to type 2, which is the most widely used type, and we will spend most of the time there. Then we will continue to type 3 and 4, which are adding a column and mini dimensions. So why slowly changing dimensions? Dimensions are not static, even though changes occur very slowly to them. So we want to track changes over time. Sometimes we want to track the history, we want to track when it happened, etc. And not every changing attribute is necessarily a fact. If you go back to the original lecture I gave about facts and dimensions, there is a strategy to sometimes move something that is usually a dimension to a fact, but you don't want to do it for performance reasons, and we will touch on that later on this talk. And different strategies of slowly changing dimensions may be applicable for different business needs on how we need to query the data and how we need to track history. And we will get to the differences when we will go through the different kinds of slowly changing dimensions. So we'll start with the first two types, which are the easiest, which is type 0 and type 1. Keep original and override. So type 0, keep original. In this case, we just do nothing when the underlying data is changing. Let's say we have a dimension and the operational database changed the some value on this dimension. We don't change it in the data warehouse, we just keep the original. So how does it look? Let's say we have a table of music albums where we track album, the artist of the album, and the genre. And let's say the genre is now changed in the operational database from rock, in this case, to metal. So in the type 0, we will not reflect it in our data warehouse. We'll keep the rock. And just to make it clear, we will probably want to mark the table in the data warehouse as original genre, in the column name or something like that. Type 1, override. Simple as it sounds, we will take the field, the column with the field of the genre, for example, and we'll override it with the new value. So how does it look? We have the table, we change it to metal, so now from rock we are moving to metal. This is useful only when history is not a factor, of course. If we don't want to know what the original was, or we don't want to track changes over time, we can just use type 1, which is very simple, as you can see. Okay, so next let's talk about type 2, slowly changing dimension, which is the type in which we add a new row to track any changes to the data. So in type 2, we track the complete history. For every change to the data, we add a new row to reflect this change. And in the new row, of course, we have the new updated data. So we don't remove or change anything in the original row, we add a new row. Additional to adding a new row, we have 3 new columns in the table to be able to tell what data is effective, from when to when it was changed, etc. So the 3 new columns we add is first, effective date. Effective date is the date in which the new row of data became the truth. So let's say we change some field in a row. So we add a new row and we change it in May 2012. So the effective date will be a day in May 2012 to reflect that. Expiration date is when the data stopped to be the current truth. So when we add a new row, the original row before that add an expiration date to the same day we added the new row. So we will know from when to when this data segment were true. And the last field is a Boolean flag called isCurrent usually. And it's true if the data is the current data. It's just make it easier to query the table. So instead of messing around with dates, you just want the current data, you query by where isCurrent is true, and you get the current state. So how does it look in the table? So what we have is the table as we saw it before, with the surrogated key, the album, artist, and genre. And as you can see here, when we changed from rock to metal, we didn't change the original, which is this. We added a new row. And then we have the dates, the new columns we talked about. So let's say the reload with the rock genre was originally added at September 2019, and we changed it in October 2020. So this is the expiration date, this is the last date it was true, and then the new field was in the day after that. This is the new truth, and the flag of isCurrent is here. So how does it look from the fact tables? When we add a new row, we need to change how we track the album in the fact table. So if we have a fact table that tracks the album ID within it, from a certain date, the new foreign key for the album will just direct to the new true, the new updated truth. So if in September 2019, before the update, the original was this key, the key that refers to the row with Metallica having the genre as rock. In October of 2020, it's already the new updated row, so we refer in the foreign key to the new row. So some best practices and notes for using things like the type 2 slowly changing dimension? First, we must use surrogated key. Surrogated keys are best practice regardless, but when we use type 2, in which we add a new row, it's an absolute must, because some people tend to use the IDs of an object from their operational database in the data warehouse, and when you use type 2, you will absolutely get to a collision because you need to add a new row representing something new. So you absolutely can't use the same ID. So you need to have some process in your ETLs or something else to generate surrogate keys. Next thing is, as you could see back here, I use the expiration date as this thing, and it's a best practice just not to have null there, so you can use all the date functions in the SQL. It's far more convenient. The last thing, and this is important, you should only use type 2 for truly slowly changing dimensions. It's very tempting to use type 2 for everything because it tracks the entire history, it have all the data, you don't lose anything. But if you use it for something that may change more frequently, let's say every day, every hour, something like that, you will very quickly find yourself with a very bloated table. And this harms performance so much that you can't have this performance hit when we talk about OLAP databases. We want analysts to be able to get the data quickly, and if you get to a point where the rows for each data point is updated multiple times a day or something like that, it's not the right solution. We will talk about what the right solution for that later on. So let's stop for a minute and talk about how the different slowly changing dimensions we saw so far are different on the business side when we query for results. So let's say we query for the sum total sales past 2 years by genre rock. And when I talk about that, I'm referring to a fact table like we saw here, where we track by date, by album, and then the facts that we track are sales and revenue amount. So let's say we want to sum the sales column. And we want to sum it by genre rock. So what will be the differences in what we already saw? So in type 0, we just keep the original regardless. So what will happen is that we will count all the sales from 2019 and 2020 because we didn't change anything. In type 1, we override. So we remove the past. We remove the rock. So we will count nothing because nothing is rock in our table right now. And in type 2, where we track history, since we look for where genre is rock, we will get just the originals, the original data from when the album was tracked as rock until it was tracked as metal. Okay? But what about history sensitive cases? What I mean by that, what about counting sales for albums changing from rock to metal? Let's say that's interesting to me. I want specifically to know how much more sales does albums that were usually marked as rock that are now marked as metal made. Or let's say we want to count sales for any album that was ever recognized as rock. Of course, this is possible with type 2, but it's not convenient and it's not the usual use case. If this is the use case, this is where we get to type 3. So let's talk about type 3 slowly changing dimension, adding a new attribute column. In this type, we will add a new column to the table to track changes to one attribute. So we will have the old attribute, the old data in one column, and in the new column we'll have the new data. Typically this is used for one-time cross-data change, not something that we expect to change again, so we don't need to add new rows or track history like we do in type 2. of course, because does not scale. You can't add more and more columns for every change. Just if you know you have cross data change and you want to keep the original, that's what you do. So how does it look? We will have the original table here, and let's say we know that we across the data we change all the albums that are typed rock to new type, or even further than that. We know that we track just the basic genres right now, and we need to now track subgenres, and instead of rock we want to track this will be marked metal. So it's across the data and we want to track this. So we had here a new column, which here we track in the new column the old genre, and in the genre column we update the data. So that way you can, for example, query all the data, all the albums, for example, that was marked as rock originally, if this is a cross data change. We are now getting to the last type in this presentation, type 4, which is called mini dimensions. So in order to talk about type 4, we need to understand the rationale behind it. And to understand it, we need to understand the type 2 slowly changing dimensions scaling issues, which we referred at the start of this slides. So in order to track history, complete history, when things changed and what changed and everything like that, we need slowly changing dimension type 2. But if the slowly changing dimension is changing fast enough, it might lead to an inflated dimension table. Think about it that you have the dimension table and just one attribute changes and you need to duplicate the row. So even if you have just a really big dimension in terms of columns, just one attribute changing fast enough will have to duplicate it again and again, and it's really bad for performance. So once we get to this big dimension table, filtering by it doesn't work. And this happens only when the dimension is changing fast enough, of course, and in terms where the dimension that is changing fast can't be facts. They can't be facts for one of two reasons. For example, you need to use them as dimensions because you need to filter by them other facts, or they're changing fast enough to cause scaling issues with slowly changing dimensions, but not fast enough to be considered facts. So how does it look? When we talk about type 4 mini dimensions, we talk about adding a new dimension to track through the fact table and not through the original dimension. So we scrape out of the original dimension a mini dimension and we track it through the fact table. So in this case, we talk about a mini dimension that is, we want to track, for example, the social media noise about certain albums. We want to track it weekly. So if we track this dimension of social media album within the original dimensions, it means every week we will have to duplicate all the data. But we don't want it to be a fact, or even though it can be a fact as well, because we want to filter other data by that. So we want to look at the sales of, let's say, the sales count of all the albums that have low social media hotness. So we need it to act like a dimension, but it's changing fast enough that we can track it within the original dimension. So things to note here is that the mini dimension is tracked through time via the fact table. So since the fact table is tracked, let's say in this scenario every day, we can get the data of when social media hotness is changed through looking at the fact table and tracking it here. But thing to note here, what I wrote here is, of course, this creates a dependence on the fact table to exist and never fundamentally change. So the data of when things changed is tracked in the fact table and not in the dimension as it would have been in slowly changing dimension type 2. And this is the last point I'm tracking here. The album dimension can be queried regardless of the fact table in normal circumstances. So if I had this, the social media hotness, as another data point as slowly changing dimension type 2 in the albums, I would have been able to track the changes over time just by looking at the dimension table. But once I'm doing mini dimension, I lose this ability. So this is one of the things to consider when you go to a mini dimension solution. So that's it. Thank you for watching this lecture by me. And I want to thank SlideGo, from which I took the theme of these slides. I'm not such a great designer. And that's it. I hope you enjoyed it. See you next time.